Wonderful students, welcome to Physics Meal. Physics Meal is still part of our Mathematics and Science Meal program that is designed to help students as far as the study of maths and sciences are concerned. Today we are going to look at calculations on accelerated motion. Remember, calculation is a very important aspect as far as the study of physics is concerned. That's why we usually give more time to calculations in the study of physics. Now, there is need for you to just subscribe to our YouTube channel and also follow us on Facebook. Our Facebook page is Mathematics and Science Meal. And our YouTube channel is Mathematics Meal 1. Just subscribe, like our videos, share our videos, and also recommend our videos to your friends. Thank you. All right. Like I said earlier, our business is on calculations on accelerated motion. Remember, motion is the change in position of a body with reference to what? To time. So once a body changes its position, motion has taken place. Now, in accelerated motion, there are two methods of carrying out calculations. One is the analytical method and two is the graphical method. In the analytical method, we use equations of motion, while in the graphical method, we just use graph. But our business today is on the analytical method, where we are going to use equations of motion in carrying out what? Calculations. All right, before we begin this calculation, there is need for us to mention some important points that will help us as far as calculations on accelerated motion is concerned. Because if we fail to know these points, in the course of our calculations, these points will be surfacing. So there is need for us to take time to understand these points. So let's note the important points. Important points. So important points to note. So what are these important points that we need to note? That's what we have to ask ourselves now. What are these important points that we need to note? One, since we are using equations of motion, equations of motion used in our calculation are V is equal to U plus 80, X is U plus V, bracket T divided by 2, X is UT plus 80 squared over 2, then V squared is equal to U squared plus 2AX. I know if you have done motion, you are familiar with these equations and you know what each term stands for, where V is final velocity or final speed in meters per second, or you can write it unit like this. U is initial velocity or speed, still in meters per second. This and this are the same. Then A is acceleration in meters per second square. Then T is time in seconds. While X is distance in meters. That's X. So all these terms, that's what they stand for. So the first point we must note here is these are the equations we are going to use for our calculation. Very important. Now the second point, so you need to take note of these equations. So the second point, when a body starts from rest, the initial velocity or speed will be zero. That is U equals 0. So when a body starts from rest, the initial velocity will be what? 0. Very important. very, very important. When a body starts from rest, initial velocity is 0. Okay, the third one, when a body comes to rest, the final velocity will be 0. So when a body now comes to rest, the first one, when a body starts from rest, initial velocity is 0. But when a body starts from comes to rest, the final velocity is 0. When a body starts from rest, the initial velocity is 0. But when a body comes to rest, the final velocity is what? Is 0. Now, the fourth one. During acceleration, or for acceleration, for retardation or deceleration, the term A will be assigned a negative sign in the equation. So if a body is undergoing deceleration in an accelerated motion, deceleration, we know that deceleration or retardation is negative acceleration. During acceleration, velocity is increasing, but during deceleration, there is decrease in velocity. So in acceleration, the final velocity will be greater than the initial velocity. But during retardation, the initial velocity now will be greater than the final velocity, because velocity is reduced. So in such cases, we are going to assign negative sign to the acceleration term, that's the A in the equation. We now carry negative sign. That what it means is that in this case, if we have deceleration or retardation, this equation will become u minus at. This negative sign is because of the deceleration or retardation that is taking place in that particular motion. This is very, very important. So with these 4 points, we can actually carry out calculations as far as accelerated motions are concerned. So I believe that these points are very clear. So we're going to take a problem, just one question, and then we'll now go on break, and subsequently we'll be solving a variety of questions as far as accelerated motion is concerned. Okay, let's move together. We'll write this equation at one corner of the board, because we'll be making reference to the equation from time to time. So we need to look at the first example. Example 1. Example 1. So, example 1. Right. Let's begin. So let's take a question on this. A car starts from rest and moves with uniform acceleration of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion. Okay? Let's calculate the distance covered by the car at the end of the motion. So at the end of the motion, what distance was covered? So let's we say we are going to write the 4 equations on one part of the board. One part of the board, we are going to write the 4 equations on one part of the board. Okay? So, let's remember v is equal to u plus at, x is u plus v bracket t over 2, x is ut plus 8 square over 2, and v square is u square plus 2ax. These are the 4 equations. So let's solve this problem. Now, I usually talk about the IC principle. Whenever you want to solve problem in physics, we talk about the IC principle. IC principle. What is the IC principle? You have this. We say identify, set up, explore, and then execute. So you need to identify the values, the variables, the parameters given in the equation. Then you set it up using appropriate symbol. For example, a car starts from rest and moves with uniform acceleration of this. There is a symbol for acceleration. So you need to use that symbol to represent the acceleration. That's what we mean by setting up. So when you have identified all the quantities given in the equation, including the one we are asked to calculate, then we set it up using appropriate symbol. When we are done with the identification and setting up, we begin to explore, to search for the suitable expression or equation or formula that can help us to solve the problem. And then once we find that suitable formula, we now execute. We now solve. So let's do this quickly. So we identify. A car starts from rest. This statement is important. Remember that we say that whenever a body starts from rest, the initial velocity is what? Is 0. So once they say that a car starts from rest, we can say that u, which is the initial velocity, is 0 meters per second. And moves with uniform acceleration of 30 meters per second. So I have identified another quantity. This statement helped me to identify initial velocity. Then this next one, through the next one, I identify the acceleration. Which is 30 meters per second squared. And now for 20 seconds, I have identified time also. They now say calculate the distance covered at the end of the motion. So distance, the symbol is what? Is x. So we have that. So we have identified, we have set up. The next is to explore. Let's go to our equation. V is equal to u plus 80. We cannot use that because we don't have any information about V. So we throw it away. X is equal to u plus V. V is still here again. We don't have any information about V, so we cannot actually find the distance using this. Then we'll come to this. V still appear. We don't have information about it. The only surviving man is this. X is equal to ut plus 80 squared over 2. So I know u, I know t, I know a, I know t. So that's the suitable formula. That's the exploration. So during our exploration, we found that the suitable expression will be this. Ut plus 80 squared over 2. So we now substitute to execute. So x becomes u is what? 0 times 20 plus a is 30 times 20 squared divided by 2. Excuse me. So 0 times 20 is 0, plus this will give me 30 times 20 squared is what? 400 divided by 2. So this is 0 plus 2 divide 400 will give me 200. Or one can multiply 30 times 400 will give me 12,000. You have 12,000 over 2. That will give me 0 plus 2 divide 12,000 is 6,000. And 0 plus 6,000 will give me 6,000 meters. So the total distance traveled by the car will be 6,000 meters. All right. So you see, it's a very simple thing to carry out calculations on accelerated motion. All you need to note are those important points that we started with, and then you know the formula, which is actually part of the important points. And then you must follow this, our IC principle. If you cannot see, you cannot solve problem in physics. Yeah, if you cannot see, if you are a blind man, you cannot, not the physical blindness, but if you are blind as far as physics is concerned, you cannot solve problem. And that's why we ask you to see, I see. So once you can see, you can solve the problems. All right, we are not done because we have a variety of questions to solve as far as accelerated motion is concerned. But we'll go on a short break. In the next episode, there is need for you to watch the next episode. In the next episode, we'll now start solving a lot of calculations as far as accelerated motion is concerned, because we have laid the foundation by giving you the important points that you need to know. Thank you for watching our video today. And remember, subscribe to our YouTube channel and follow us on Facebook. Help us grow this page and help us grow our YouTube channel. Thank you and God bless you.